Hello friends, welcome to CEC live lectures. Dear friends, with our ongoing series on quantum chemistry, today we are going to talk on properties and applications of a one-dimensional box. And for this discussion on the topic, we have with us in our studios Dr. Amita Dua. Dr. Amita Dua is Assistant Professor in Department of Chemistry, Dayal Singh College, University of Delhi. Dr. Dua has immense knowledge as well as immense experience too. She has authored number of books and number of articles have been published in reputed journals too. Friends, if you want to ask questions from Dr. Amita Dua on today's topic, then do call us through our toll-free number. Our number is 1800-110-430. I repeat, our number is 1800-110-430. All friends are requested to call in the last 10 minutes of the lecture so that first you could have deep insight into today's topic, and yes, of course, we will try to give answers to your questions through Dr. Amita Dua. Friends, now I would like to request our guest Dr. Dua to continue with the lecture and explain us in detail about today's topic. Hello ma'am, welcome to the lecture.
So hello to all my friends, and in the last few lectures we were discussing about how we have derived the wave function as well as the expression for the energy for one-dimensional box, and then after that I have also discussed about the conclusions what we have obtained from the 1D box. And now I'll continue with the same topic, that is 1D box, and today I'll do the solution of the properties, some of the properties like the position, the momentum, the square of the momentum, the linear momentum, that how to solve, how to get the expression for those properties for 1D box, and after that I'll also try to discuss the application of one-dimensional box. So now once the wave function is obtained, that is a wave function is the storehouse of information for 1D box. Once the expression for the wave function is obtained, because all the information is there in the expression of the wave function. Now out of the wave function, how do we get the properties, how do we solve the properties of the one-dimensional box? So to get the properties, there are two expressions. The first one is Eigenvalue Equation. The Eigenvalue Equation is the one by which you can get the value of a property, that is a constant value of a property. So first is my Eigenvalue Equation, and that is A operator wave function equals to small a into psi. That is, now what is the operator? I have already discussed that in the quantum mechanics for every property there is an operator, that is there is a command. So like if we have momentum, we have an operator for the momentum, that is P operator. If we have energy, we have H operator, and then we'll apply that H operator or P operator. Here we have written the generalized this thing, that is A operator. When it is applied on the wave function, that is psi, we'll get a constant value multiplied by the same wave function. So this is how, so the value of A operator is small a. So this is how we can calculate the solution, the value of a property of the system. So this is known as Eigenvalue Equation. So my A operator is, that is operator of the property, and A is my eigenvalue of the property, which should be have a constant value. In case you did not, one is not able to get a constant value, then we try to get some average value. So by Eigenvalue Equation, we try to get a constant value for that property. In case we do not get the constant value, then we have to switch over to get the average value, which is known as mean values theorem. So first we always try to get the constant value by using the Eigenvalue Equation, and in case we do not get that constant value, then we will switch over to the mean value theorem. And my mean value theorem is A, that is in brackets, that is the average value, or A, the upper bar, that is average value, which is integration of psi star into A operator into psi d tau divided by, that is in the denominator, again integration of psi star into psi into d tau. So this is how the average value of a property is obtained. So now we will start with how you can calculate the various properties of one-dimensional box. Now first I'll start with the position. we'll do various, there are on the whole there are 6-7 properties which we will do today. The first one is position. Just concentrate on the how we solve this thing. First, we always try to get the constant value, that is, I'll apply the eigenvalue equation to get the constant value of the position, that where is that particle located in the 1D box. So that is, we solve for exact position using the eigenvalue equation. So now what is the operator for the position? That is, x operator is x simply, and our wave function for 1D boxes, we have already solved this, that is under root 2 by a sine n pi x by a. This is, I think, clear to everyone that what are the expression for the wave function. Again, I have told you here only that the wave function for psi, the wave function for the 1D box is psi this and this. Now I'll apply the eigenvalue equation, that is, x operator is applied on the wave function to get the value of x operator. So once when x operator is applied on psi, then what would be my answer? X into under root 2 by a sine n pi by x by a. Now, is there any constant value which is obtained by applying x into wave function? No. The x is again a variable. Nothing is obtained. So, psi is not an eigen function of the position operator. That is, by this means that when I apply x operator onto the wave function, no constant value is obtained, none of the value is obtained. So this does not satisfy the eigenvalue equation, that is, we cannot get the exact solution for the position of the particle in 1D box by using eigenvalue equation, and that is why we have to apply the mean value theorem, that is, we have to find out the average value of the position. We are not able to get the exact value. Now, what is my mean value theorem? The same formula which we have to apply. Using the mean value theorem, that is, x bar, or in the brackets, that is integration of 0 to a. Why 0 to a? Because the length of the box was 0 to, the limits were 0 to a. Psi star into x operator into psi dx. Why dx? Because it is one dimensional box, that is why I am not taking d tau. D tau is generalized formula here, because we are taking the 1D box, that is why I have to restrict myself to dx or dy or dz, because I am taking x operator, that is why it has become dx. And then in the denominator 0 to a, psi star into psi into dx. Now I have to put the values of the wave function. What are the values? Is there any iota? No, there is no iota. So hardly it makes any difference between psi and psi star. Here my psi and psi star are same. So because psi star means that is the complex conjugate, because there is no iota, so there is no difference between psi and psi star. So just by putting the values of psi and psi star, my psi star would become, that is under root 2 by a sine n pi x by a into my x operator is x. Again my psi is under root 2 by a sine n pi x by a into dx. In the denominator, I would have 0 to a, that is the same expression, psi star into psi. I have just put it the values of psi star in the numerator as well as the denominator, and integration over dx. Now first I will solve the numerator, because it is a different integration we haven't solved earlier in any of the lectures. That's why I want you to see all the equations so that it becomes more easier for you to understand from any book or from this lecture. So just try to concentrate on over here. Actually, although it needs a simple integration and differentiation and nothing else, but still just see over it. Suppose for the numerator, I have 0 to a under root 2 by a sine n pi x by a, that is my psi star, and then x, and then what is my psi? Under root 2 by a sine n pi x by a into dx, right? Now, because under root 2 by a and under root 2 by a, they are constant and they are in under root, so I multiply both of them, it becomes 2 by a, which is taken out as a constant, so it will become 2 by a integration x, because x is there, and sine is twice, so I have converted into sine square n pi x by a into dx. Now there is nothing, how can you solve the square thing? So obviously I have to convert sine square into cos function. So how it is converted? I have given this in the brackets, you can see on the slide, it's written 2 into sine square x is 1 minus cos 2x. Then what would be your sine square x? It would be 1 minus cos 2x divided by 2. So this is the simple formula to make the integration simpler. So instead of sine square x, I have written 1 minus cos, because it is 2x, so it becomes 2n pi x by a, it's a function, on the whole divided by 2. So simply you can see on the slide, I have just put it sine square, instead of sine square I have put it 1 minus cos divided by 2. So this is how it is simplified. Now in the denominator there is 2 gets cancelled from the 2 which is out of the integration sign. So 2 gets cancelled by 2. So we are left with 1 by a and then x 1 minus cos 2n pi by x by a. Now I will multiply x 1 by 1. First I multiply x with 1. So it becomes x into dx. And then again, because I am opening the brackets, that is why it looks like this. And then it becomes 1 by a, again 1 by a, because I am multiplying with the whole bracket. So it becomes 1 by a x into cos 2n pi x by a into dx. Clear? Now I will integrate 1 by 1, that is there are 2 terms. 1 by a, on integration of x, it gives you x square by 2, right? And then what are the limits? 0 to a. Again minus 1 by a. Now I have x into cos 2n pi x by a, which I have to integrate, which I will integrate by using the formula of whenever 2 things are multiplied. That is using the integral, because the first term is very easy to solve, there is nothing, it is simply the integration of x, you just have to put x square by 2 and then putting the limits, it will get solved. But the problem is that actual integration is in the second term. So I am telling you the formula, you can see on the slide, the simplest formula, that is if the product formula, that is using the integral, that is suppose there are 2 integrals, first and second. So integration of 1 and 2 dx, that is first, into integration of second minus integration of d by dx of first into integral of second, and then the total integral. So this is how the second term is to be solved. Now I will put the second term, I will solve the second term by using this integral. It will become, because in the first one I have just put it a and then 0. So this will become 1 by a, in the brackets it is becoming a square by 2 minus 0. So ultimately it is a square by 2 and I am cancelling the 2 a's and I am left with a. But in the second term you can see this is 1 by a because it was already there. Now putting using the formula, that is in the brackets first function, that is x, into integral of second, that is integration of cos 2n pi x by a into dx, bracket closed, and then again minus integration of, bracket start, d by dx of first, that is d by dx of x, into integration of second into dx, that is what is my second this thing, that is cos 2n pi x by a into dx, and then bracket close. So I have just put it, my first integral is x, my second integral is cos 2n pi x by a, and I have just put it the values instead of first and second, and this is what is obtained. Now my first expression is a by 2 because a square gets cancelled by a, so we are left with a by 2, and then in the second expression is minus 1 by a. Now x will remain as such, x will remain x, and then we have integral of cos. Cos on integration gives you sine, so this will become sine 2n pi x by a, and because the constant in the integration, the constant is also divided, in the differentiation the constant factor is multiplied, but in the integral that the same thing comes in the division. So divided by 2n pi by a. Next bracket, that is minus integration. I am putting the limits, that is 0 to a. Now d by dx of x, that is it is a differentiation, so it will become 1. Integration of cos, it will give you sine, that is sine 2n pi x by a divided by constant, that is 2n pi by a, and then dx. Again we have to do one more integration, the last term. So now we are left with a by 2 minus 1 by a in the brackets. Again I have, because I am also putting the values of that is the limits, that is 0 to a. So when I put the value in the first this thing, it will become a, that is instead of x I have put it a, and then the one which was there in the denominator, that is 2n pi by a, now it has converted into a into 2n pi, and then I'll put 0 to a into sine n pi x by a. Once a is put it, a gets cancelled with a, so I'm left with sine 2n pi, and once 0 is put it will become 0 because sine 0 is 0. Then come to the third term, that is the integration, where still integration is to be done. That is, see, already 2n pi by a was there in the bracket, so I have written a into 2n pi, and then I have to do the integration of sine 2n pi x by a again. So on the integration it will give you, because sine on integration will give you minus cos, and again the constant will again come into the denominator, so it will become minus cos 2n pi x by a divided by 2n pi by a. In the integration, in the limits, that is 0. So by this all the integration part is finished, and now I'll put the value, that is the limits. So it will become a by 2 minus 1 by a. Now sine 2n pi, all the integrals, that is 180 degree and all those, they are always 0. So by this 2n pi is also 0. So in the first bracket, in the second term, that is a into a 2n pi sine 2n pi, this whole thing will become 0. So 0 minus 0 will make the term full and final, that is 0, and then minus, else getting on to the next term, that is a into 2n pi, the 1 2n pi into a which was in the denominator, now I'll reciprocate it, so again it will become a into 2n pi, and then multiply by minus cos 2n pi x by a, that is the integration limits. So by this thing my first term is there, but in the second term the first factor becomes 0 because sine 0 and sine 2n pi was 0. So now I am left with what? That is a by 2 minus, because first thing is getting cancelled, so it is 1 by a. Now already 1 minus is there and minus cos is there, so minus minus become plus. So in the brackets we are getting rid of that minus sign and we are left with the positive sign. So it will become a by 2 in minus 1 by a, and then a 2n pi into a 2n pi would become a square into 4 n square pi square, and then in the brackets we have cos 2n pi x by a within the limits, that is 0 to a. So now we have a by 2 minus my 1a, one of the a is getting cancelled with a square. So I am left with a into 4n square pi square, and then in the brackets cos 2n pi, because now I am putting the limits, that is first I'll put a, so it will become cos 2n pi, and then I put cos 0, so it will ultimately become x as 0, so it will become cos 0. So now cos 2n pi is also 1 and cos 0 is also 1. So 1 minus 1 will become 0. So finally we are left with, that is a by 2. So the expectation value, because we did not get the exact value by the eigenvalue equation, that is why we have jumped to the mean value theorem to get the average value, and my average value comes out to be a by 2. Now also not the average value, because we are also left to solve the denominator. We have just solved the numerator, because finally the denominator will come out to be 1, That's why I was saying that it is a by 2. So this is how we have solved the numerator, and in the numerator value we have got a by 2. Now we'll come to the denominator part. What is my denominator part? That it is simply psi into psi star into dx. Now what is my psi? That is solving the denominator. I have done into 2 steps. That is, first I have solved the numerator, then I am solving the denominator, then I will divide the 2 so that to get the mean value of the position operator. So see the slide we have got, that is I am solving the denominator, that is 0 to a and then under root 2 by a sine n pi x by a into under root 2 by a sine n pi x by a. If any of the student does not know how to solve, because by looking it looks very tough that how will you solve all these things, but the simple trick is that you should know the simple formulas of the differentiation, integration, and the differentiation and integration of the simple trigonometric terms, that is sine and cos, and nothing more than that. No tan, no cosec, nothing but simple sine and cos. If one student knows how to do the simple integration and differentiation of x, sine and cos, then you will be able to solve all these lengthy calculations. So now come to the point, that is under root 2 by a and under root 2 by a, once it is multiplied it will come out to be as a constant, that is 2 by a, and then integration of 0 to a sine square n pi x by a into dx. Whenever there is a square term, always try to get rid of it. Convert it into, suppose there is sine square x, convert it into cos. Just get rid of the square term. So now because I have got, now I have n pi, but this integration I have already solved in I think 4-5 lectures back, when I want to solve, when I was doing the normalization of the wave function. At that time we have discussed this derivation, which again we have come across. So now in this I will put n pi x by a equals to y. Because I have put it this as y, so obviously I have to convert dx into dy, and once dx is converted into dx by dy, then the limits will also change. So my n pi x by a will become y. I will differentiate this thing. So it will become n pi by a, x will get converted into dx, and my y will become dy. So what is my dx? Because I have to convert, now I have to convert everything in terms of y. So my dx will become a upon n pi, I have taken on the other side this thing, so it will become a upon n pi into dy. Now I am already told you that once this thing is changed, I have to also convert the limits in terms of y. So I have n pi x by a equals to y. I will apply the boundary condition. When x equals to 0, put x equals to 0 in this term, everything will become 0. Then my y will also comes out to be 0. If I put x equals to a in n pi x by a, so a gets cancelled with a, so I am left with y equals to n pi, and therefore I will put both the limits. Instead of 0 to a, it will become 2 by a integration of 0 to n pi sine square y into, because already what was my dx? Dx is a into n pi by y. So instead of dx, I have put it a into n pi by dy. Now I have already told you, whenever there is a square term, just get rid of it. We already have 2 into sine square, we have a formula 2 into sine square y, which is 1 minus cos 2y. So what would be my sine square y? It is 1 minus cos 2y divided by 2. So instead of sine square y in the above expression, that is in the first one, put 1 minus cos 2y divided by 2, and a upon n pi is taken out of the integral, and change the limits from 0 to a to 0 to n pi. And then the simple integration is done, and by this we get the numerator value to be as 1, because already I have discussed this integration, so I am not discussing the same derivation again and again. So by this we get 1, and thus my numerator was a by 2 and my denominator is 1. So on the whole I get the average value of the position to be as a by 2, and this shows that particle in a box, it lies somewhere in the middle of the box. So I'll also discuss more and more properties, that is x square, the position and the square of the momentum. But before that, I'll take a break. Thank you.
With this note, thank you, ma'am. Thank you so very much for giving us a productive session. Friends, we would be continuing further and would be discussing more under today's topic. For that, you need to be with us. We will be back after a short break. Hello friends, welcome back to this session where we are discussing on the properties as well as application of one-dimensional box. In previous session we learned a lot, and we believe that in this session also we are going to give you more and more knowledge and information. And for this discussion we have with us in our studios Dr. Amita Dua. Now if you want to ask questions from Dr. Amita Dua on today's topic, then do call us through our toll-free number. Our number is 1800-110-430. Now I would like to request Dr. Amita Dua to continue further with the derivative part which we are going.
So my friends, we have discussed about how to calculate the position of the particle in a box, that is position of a particle in a 1D box in the first session, and now I'll continue the same. That is, now we'll do the square of the position. Again, first of all, we'll apply the mean value theorem just to get the exact value. In case you did not get the exact value, then we will switch over to the mean value theorem. Now just check what about the square of the position. That is, first, what is the operator for square? It is simply for the position, it was x operator. The thing is, that is x. And then for the x square, that is square of the position, it is simply x square. So now when x square is applied on the wave function, so it will become x square into what was my wave function, that is under root 2 by a sine n pi x by a. So when I apply x square on the wave function, is there any constant value you would be able to get? No. So will you able to get any constant value? Because the answer is no. So obviously the exact position, the exact value of the square of the position cannot be obtained in case of particle in a box. So thus the wave function is not an eigen function of the square of the position operator. That is, it does not, again the same thing I'm telling you, it does not satisfy the eigenvalue equation, and so we have to apply the mean value theorem to obtain the average value of the square of the position. Now I'll do all the derivation part with you, so as the thing will become more clear to every student. Now using the mean value theorem, because we have to calculate the average values, I will apply the mean value theorem. That is, my limits are 0 to a. The only thing is that instead of x, now I will use x square as the first function. The only difference which you can see is that when you will apply the integral, that is first function into second function, the only thing that the difference come in that integral. Instead of x, we will apply x square. So this is psi star into x square into psi into dx, and then integration of psi star into psi into dx. So we have in the numerator we have 0 to a. Instead of, because there is no iota, again psi and psi star are same. So it is under root 2 by a sine n pi x by a into x square, again into under root 2 by a sine n pi x by a into dx. In the denominator, under root 2 by a sine n pi x by a into under root 2 by a sine n pi x by a. Simply instead of psi and psi star, I have used the wave function expression. Because there is no iota, my psi and psi star expressions are same, as simple as possible. Now first of all, I will solve the numerator and then I will solve the denominator. In the numerator, I have 0 to a under root 2 by a, that is the same expression which is written. Under root 2 by a and under root 2 by a, this will come out as it is. So we are left with 2 by a and then integration of x square into sine square n pi x by a into dx. I am telling you again and again, whenever there is a square term, it is not possible, for that the integration is not possible. We have to convert it into the simpler terms. So instead of, in the brackets you can see on the slide, we have a formula 2 sine square x equals to 1 minus cos 2x. So sine square x will become 1 minus cos 2x divided by 2. Take this expression and simply just take it and put it in the above expression. So instead of sine square n pi x by a, in the brackets I have written 1 minus cos 2, because it is 2x, so it is cos 2 n pi x by a on the whole divided by 2, because I have cos 2x divided by 2. Now I will multiply x square expression with the brackets. So this will become 1 by a was already there, and then I have x square multiplied by 1, so it is x square into dx, again entering, that is 1 by a, and then integration of x square is now multiplied with cos 2 n by x by a, and because already there was 2, so 2 was cancelled with the 2 which was already out of the bracket. So we don't have 2 by a, we have 1 by a, which I am multiplying with both the expressions. Now I will solve the first term, that is x square. The integration of x square is, because in the integration it is x to the power of n plus 1 divided by n plus 1. So 1 by a, it will become x cube by a, that is, and then integration of 0 to a, minus 1 by a, and then in the integration we have x square cos 2 n pi x by a. This is the same, these are the same steps which I have done in the last derivation. I am going in the same way. Now using the integral, I have to use the formula, that is first function into second function into dx. What is the formula? First function into integration of second into dx minus integration of d by dx of first into integration of second, and then bracket close. Now my first term, because this is the first term we have to solve, that is 1 by a, which was x cube divided by a. Instead of this I will put the limits, that is 0 to a, it will become a cube by 3 minus 0. So simply we land up to a cube by 3. Now put this aside. Now we will solve the integral part. This is 1 by a, and then I have to solve this integral, that is in the brackets I have first function, that is x square, and then integral of second, that is integral of cos 2 n pi x by a into dx, bracket close, limits, minus integration sign. What we have after the integration? D by dx of first, that is d by dx of x square, into integration of second, that is integration of cos 2 n pi x by a into dx, bracket close, and then dx, because on the whole we have to do the integral part. So now we are left with a square by 3, you can match it with the earlier expression. We have 1 by a in the brackets a cube by 3. So a gets cancelled with a cube and we are left with a square. So just see, I have a square by 3 minus 1 by a was already there. Now in the brackets I have x square. So I have already written x square. And then I have integration of cos 2n pi x by a. So I have written x square. Instead of cos, I have written sine 2n pi x by a. The constant also comes in the denominator. So we have 2n pi by a. And then I have got the integration of what? 0 to a. So I have got d by dx of x square. So this will give you x square integration the differentiation of x square. This is written as 2x. And then I have integration of cos 2n pi x by a into dx. So this will get converted into sine 2n pi x by a divided by 2n pi by a. Again bracket close. Again we have to do the integration once again because there is x square. So that is why we have to integrate it twice. So it becomes more lengthier in case of x square. So I am just carrying on to this. So this will become a square by 3 minus 1 by a. By putting because we'll solve steps one by one, once integration is done, just put the values. Once integration is just put the values, don't wait for this thing. So we have x square and sine 2 n pi x by a and all those things. So just put 0 to a. So first is a square, 2 n pi by a which was in the denominator. Now just reciprocate it, it will become a upon 2 n pi. And then put a, this will become sine 2n pi, and then sine 0, this will become 0, and 2n pi is already 0, so in the next term this will comes out to be 0, but just wait. And then we have integration of 0 to a, and then we have 2x, so it is already 2x. There was 2n pi by a, it will become a into 2n pi. And then sine 2n pi x by a. So first I am trying to cancel out the simple things, the common things, so that my further integration would become more simplified. So 2 gets cancelled with 2, and then we are left with, that is because 0 is already there and sine 2n pi is 0. So on the whole my second term becomes 0. So we are left with one integration is also left. Taking the constant terms out, that is a upon n pi. So we are left with x into sine 2n pi x by a into dx. So this is the integral which we are left with. So the final thing which we have landed up to, that is a square by 3. Now my minus is already there and 1 minus is within the brackets. So minus will become plus. It will become plus 1 by a upon n pi. I'll do the integration, but in the end, once the further things gets rid of, or I'll vanish of all these things, and then we'll land up to the last integral. So this is 1 by a, and then a upon n pi, and then we have 0 to a x into sine 2n pi x by a into dx. Within the limits, that is integration 0 to a. Now I have to solve the integral, that is x into sine 2n pi x by a. You can see on the slides very simply every step is given, and all the calculations and all the cancellations are all done for you. So now we have, again we'll use the integral because we are left with the term x into sine 2n pi by x by a, that's why. So we have a square by 3 which is already present because of the first term, plus 1 upon n pi because all the constant terms have taken out. So we are left with 1 upon. Now the last integral, that is x into integration into x into sine 2n pi x by a into dx. So this is solved. So again, what is the, when we open this or when we put all these values, then we get first function, that is x, into integration of second, that is integration of sine part, minus integration of d by dx of first, that is x, into integral of sine, that is sine 2n pi upon whatever this is. So we have a square by 3, 1 upon n pi, x, sine on integration of sine we get what? That is minus cos. So this is minus of cos 2n pi x by a divided by 2n pi by a, minus d by dx of x is 1 into on integration of sine gives you minus cos. So it is minus cos 2n pi x by a upon the 2n pi by a. So by this thing, the at least integrations gets finished. Now is 1 upon n pi, instead of x, because there is no integration, so I am applying the boundary conditions. Instead of x, first I will put a. So this will become a, and minus sign is there. So it is minus a into 2n pi by a, which was in the denominator. I will put it into the numerator form, that is reciprocate it. It will become a into 2n pi into cos 2n pi, because instead of x, when we put a gets cancelled with a, so we are left with 2n pi, and then cos 0. My cos 0 becomes 0, so this is 0, this will get vanish, and then in the see the next bracket, this is a upon 2n pi integration of cos 2n pi x by a. It's a bit lengthy derivation which we are doing. This is a square by 3 plus 1 upon n pi, because in the because in the first expression when you see, we have 1 upon n pi minus a 2n pi. So when we put this value, this will become a square 2n pi, 1 upon n pi was already there was no confusion, minus is there. Now this is a square, a gets multiplied by a, so this will become a square 2n pi. This is what we have written, and cos 2n pi is also 1. So this is minus a square 2n pi, and that's why I have written 1 into the brackets. And then I have a 2n pi. Instead of cos, on integration this will become sine by giving one more constant multiplied. So this will sine 2n pi x by a divided by 2n pi by a, and then in the brackets, that is by applying the limits, that is 0 to a. So you can see that this will become a square by 3, 1 upon n pi in the brackets minus a square upon 2n pi plus a 2n pi is also there into, reciprocate the thing which is in the denominator, this is again a into 2n pi, and then sine 2n pi x by a. Putting the values that is limits 0 and a, the things get cancelled. So my whole thing gets 0, and I am left with a square by 3 minus a square 2n square pi square. So this is the value which we get in the numerator part. When we solve the denominator, that is in the denominator I have psi into psi star with me. So my psi and psi star, you already know that they are same. So this is under root 2 by a sine n pi x by a into the same thing, which is 1, because again I am not solving the same thing. I have already solved this expression so many times when we are doing the normalization, and again. So that's why the average value for x square will become a square by 3 minus a square by 2n square pi square divided by 1. So my final expression is a square by 3 minus a square upon 2n square pi square. So this is the expression for that is the average value for the x square. Now in the first part, we have also discussed how to get the average value of the position, that was a by 2. We can also calculate that average value of x from this x square expression, because this is generalized thing. Whenever you have a square part and you take the square root, then you will get the value of x. So that also I want to show you here also, that my answer will comes out to be same. Just see the slide. That is, from the x square we can also calculate the value of x, which is same. Now my expectation value of x square is what? A square by 3 minus a square 2n square pi square. This we have derived. Now taking the under root, the whole thing, a square by 3 minus this, take a out. A square, when the square root, under root of a square is taken, obviously we will get what? A. Under root of 1 by 3 minus 1, 2 into pi square, that is 3.14 square, and putting n equals to 1. Suppose, to make the thing simplified, I have put it n equals to 1. So this is 1 by 3 will give you 0.3, 2 into 3.14 square will give you 19.71. So 1 by 3 is 0.3 and 1 upon 19.71 is 0.05. Anyone can calculate, very simple division. And 0.3 minus 0.05 is 0.25. And when I take the under root of 0.25, this is 0.5, that is 1 by 2. So from x square also we can calculate by taking the under root of the value which is obtained. By taking the under root, we can again calculate the average value of x, that is a by 2. So we have discussed two properties today, that is the average value. The first thing is that we always apply the Eigenvalue Equation, and we try to find out the constant value of any property by using the Eigenvalue Equation, and in case we do not get the constant value, then we go for the mean value theorem, that is we try to find out the average value. You don't have constant, then try to find out the average value. So I have done this thing for the two properties, that is the position as well as the square of the position, that is for x and x square. And now I'll do one more property, that is momentum in the x direction, that is px. And for everything you should know the simple integration, differentiation and the expressions for the operator, and that's it. So again we will solve first, obviously we will try for the constant value of the momentum by using the Eigenvalue Equation. So we solve for the exact momentum, that is always we always try to get the exact value, that is the exact momentum using the Eigenvalue Equation. So we have what is the expression for the px, that is h cross by I d by dx. This is the momentum operator in the x direction, and my wave function is under root 2 by a sine n pi x by a. Using the Eigenvalue Equation, we have px applied on the wave function psi. So we have h cross by I into dx, just put the two values in the expression and nothing else. So it is h cross by I d by dx. And then what is my wave function? Under root 2 by a sine n pi x by a. So this is h cross by I, and then I am taking under root 2 by a as constant, and then d by dx of sine n pi x by a. So by this we have h cross by I under root 2 by a. Now once d by dx of sine is taken, sine on differentiation will give you cos, and the constant will also come out in the multiplication part. And so we get pi by a as a constant out of the brackets, that is in fact n pi by a or whatever, that is pi by a. So this will become into pi by a, and sine will get converted into cos. So we are left with what? H cross by a, pi by a, and then to get the wave function, the expression for the wave function, I'll put under root 2 by a in the brackets. So this will give you under root 2 by a cos n pi x by a. But by this what happens? My wave function does not remain as such, because the function is changing from sine to cos, and thus the wave function is not restored. It is not same as it was earlier, and thus we cannot get the exact position for the momentum of the particle in a one-dimensional box, and that is we cannot get the constant value for the momentum for a particle which is moving in a one-dimensional box, and thus we have to apply the mean value theorem to find out the average value, and thus we have to switch over to the mean value theorem, because for the eigenvalue equation you have to have the wave function have to have the same when the operator is applied, but there is a change. In this case we have a change from sine to cos, and that is why the wave function is not same as it is, and we have to apply the mean value theorem. So my mean value theorem is what? Again the same thing, that is psi star. Into this thing we have taken x and x square. So now we'll take, that is instead of x, I'll take px into psi into dx, and then in the denominator that is psi star into psi into dx. So this is my px under root 2 by a. I'll put the values of the wave function, of the momentum, and again of psi in the denominator, that is the two wave function. So now I think everyone should try this, that how to solve. Otherwise I'll discuss the whole thing in the next lecture also, that how, if there is any problem you can also ask me. So this is how we have solved, although the method of solving this expression is a bit different, but I want you to also solve this problem. So by this my average momentum value will comes out to be 0. So now by this the average momentum of a particle moving in a one-dimensional box is 0, and which shows that particle in a box cannot continue to travel in one direction only. So however exact momentum cannot be calculated, we have got the average value, that is 0. That is it is not moving at all in a one direction. Since a moving particle cannot have 0 momentum, because the particle is already moving, so there is a contradictory statement, and therefore it means that, but the answer is coming out to be 0. So this shows that particle possesses equal momentum in the opposite direction, which cancel out, because it is a vector quantity, which cancel each other on taking the average, that is on the either direction, that is px as well as minus px. So on an average answer comes out to be 0. Now because I have taken the momentum, now I am taking the square of the momentum. Again we have to check the exact value, that is px square. So what my px is h cross by d by dx. So my px square would be, because there is iota, I into I is minus, so it is minus h cross square del square by del x square. My wave function is this. Again we have to apply the eigenvalue equation. So this would be px square into psi, that is minus h cross square del square by del x square. In the brackets I have under root 2 by a. In this case I will take under root 2 by a out of the brackets, and minus h cross square is already there. So on differentiating sine twice, first sine will get converted into cos, and then cos will again convert it into sine. So by this, when I rearrange the expression, again I will get the same wave function. You can see that on the, although I have got one constant, that is n square h square by a square, but again the wave function is restored. So by this, therefore because eigenvalue equation can be applied on, that is px square into psi will give you a constant multiplied by the same wave function. So that constant value is the exact value of the square of the momentum, and thus the exact solution for the square of the momentum can be applied. So no need to do all the lengthy calculations for the square of the momentum, which we have done for the position, for the square, and for the linear momentum. So in the next lecture we will also discuss more of the properties like the variance as well as the kinetic energy, the potential energy, and many more properties. So thank you for today. Thank you.
With this note, thank you ma'am, thank you so very much. And dear friends, we would be continuing further from the point where we left today. Friends, if you have any feedback or questions to be answered, then do write to us at info.cec@nic.in. We will be uploading this lecture very soon on YouTube. So keep watching us, keep writing us. We put meetings soon. Till then, take care. Goodbye. Thank you once again.